Hello, so what's in this video? It's about how do I go from bracketed raw files that I took with my manual lens to HDR image using Affinity Photo. Manual lens, in my case, doesn't have any contacts with the camera, so it doesn't tell the camera about its focal length or aperture being used, etc. So I will fix that first. And second, when taking picture of very high dynamic range, like the one where the sun present and you have extra set of bracketed photos using ND filter, you want to correct Exif information so that all images, like all 14 in my case, are in the same exposure world, if you can say. And then in the end, I'll show how using my Python script I can inspect resulting high dynamic range image. All right, so let's start with example of an image taken with this lens. So if I look at this raw file, you can see that it says ISO 100 because that's camera setting, and exposure 150th camera sets this, but aperture and focal length are all 0. So the first thing I will do is I will use this thing. Yeah, I will use this thing on all the CR3 files where I'm specifying aperture value as well as some information about the lens, also f number. So the aperture value. I know that because I manually set this during the shoot and I know what the actual aperture value was. So when I run this command, it will update for all CR3 files. Speaking of which, because all this about making HDR panoramas, the first thing I would do is I collect all the images into location folder, in this case Megalong Valley road shot. I've removed all the JPEG files into own folder, and then I've collected all 7 images without ND filter into this direction A, so there will be like B and C. In this case, all these images are here, and then I have with ND filter. With ND filter, I just separated them for, you will see why, and I run this command. Yeah, so Exif tool will generate this original thing, which in my case I'll just delete. And now if I look at one of those images, this one for example, and I drop it to Affinity Photo, you will see that it says that aperture is f8, exposure value is still there, and focal length is 8 as well. So that's good. That have been compensated and explained. So I'm not sure if Affinity Photo will be using this information while doing HDR stitching, but at least other applications like PT GUI, they definitely want to know the exposure values. Okay, so now going back to this with ND filter. So let's see. This was a picture taken with, let's see, 1/13 second of speed without ND filter, and I can tell for sure that let me go back. So out of all, this is the brightest. Out of all pictures taken with ND filter, this is the brightest. So I know that this picture was also taken with 1/13 of a second. You can see. So this is also exposure value says 1/14 of a second, which was the value set by the camera. But it was using ND filter on top of it, and in my case it's ND10, so it's 1024 times less light. So what I want to do is I want to change exposure value on this picture to make it seem like it was taken with much faster shutter speed. So I will change the shutter speed, which will be 1024 less light. Again, this picture will have equivalent shutter speed for that, lighting environment as if taken without ND filter. For that, I've created this program. Well, I didn't create it as ChatGPT, but I understand what's happening here. And basically, it goes through all CR3 files in the folder. It extracts shutter speed value from Exif information. So like in this case, it would be something like 1/13 of a second. And then it divides this speed by 1024, which is 10 stops compensation, and then rewrites the information. So let's go here. The script called add ND compensation. So if I run this, then it will create compensated variant. Now if I look at this image, you can see that in this particular case that would be equivalent of 1/12,000th of a second, and the one that was the dimmest one where the sun is not even clipping, that would be 1/300,000th of a second. Now we have this, merge them in Affinity Photo. I will remove that check all the checks. So what do? We go to direction A, we pick all the normal ones. Actually, let's see what happens if we do it without ND filter ones. Yeah, so let me just show you. Okay, let's do it. So if we do that, it will merge the HDR. And now I can go and export this picture as EXR 32-bit floating export. Let's call it without ND filter photos. It will. Okay. Let's go and find it. Now let's do this. I have this script here, this one, which will generate a fancy image showing the histogram for this picture. Let's see how to use it. I forgot. So histogram. All right. So if I do this, it will make this picture. And if you look at this picture, it is quite, the range is big. And most of the stuff is combined is over here. So let's just limit it and see the picture in this range. So it's 0082. So for that, I will say x min 0, x max 0082, was it? The picture it will make, yeah, so you can see it shows much denser portion of it. We can do 0009 to show like this section of the image. So now this is the most of the values and everything else is much, much brighter. Now we have this in mind. Let's go back and create HDR image with all available pictures. Ones for the bright stuff and also these guys. The ones that were compensated and then defiltered ones. Right, so that image already looks much brighter. Let's just add exposure compensation just to show the range. So yeah, so this is the range. It's going from this to this, from this to this. Okay, so in our case, we're not going to do that. We will just store, we'll do export and we call it direction A with ND filter. So I'm exporting again. Yeah, wait, did I say? Yeah, EXR. Okay, so this is the new image. Now let's look at that one in our preview histogram application. So if I look at this one now, so that's the direction A. Yeah, so what we can see is the range is much bigger if we look at two images. So this one goes from, for whatever reason, minus 0.6, I don't know, we can ignore that, to 132,000, whereas the first image was going to 1 from 0. And you can see that this one big massive gap, and that's the dynamic range gap. We can drill down and see the details of it as well. So if I go to 1000, so I will look at the sliver in this section here. So from 0 to 1000. Yeah, it didn't do us much better, so we need to go even closer. So let's go 30. Here's the 30. We can go to, I don't know, 2. So yeah, this is the internal section of where the most of the pixel values are distributed. By the way, I'm using not all pixels, like most of the pixels will be over here in this section. So yeah, so I can go to 007, this particular case. Yeah, so that's where most of the pixels are. And yeah, so that's in this section, and then it goes, the dynamic range continues, and then finally, continues to 1000, and then finally, right, it's the first one, it's this one, and it goes all the way to 100,000 values in this high dynamic range image. The one thing that I thought, I'm not sure how it changes things, but I was thinking, what if I, make it somewhat reasonable to look at, and what happens then? And I tried. So if I compensate exposure minus 3, and yeah, you can see, so it's on top of that thing. And then if I now export that image, how will it look on histogram and so on? So now direction A with ND filter, EV, so minus 3 EV. Let's save that image. So here's our image. So when you look at it, it just looks a bit more expected than this blown out, so you can see at least a bit of sun. And so if we now inspect this image, what will we see? This one. It looks like the one that we made previously without exposure compensation, but you can see the values are going now up to like 12,000. So instead of 100,000, it's now 12,000. And trust me, so I tried and I went down and drilled down. I think it's not changing the density of information. All information is there. It's just scale of all the numbers went down a little bit. And it seems like when you're looking at this picture on like in preview, it will show it like this. So I don't think there's any difference if you compensate it or not. So you can compensate it and then so that it's better to look at. And that's pretty much it what I wanted to show. Yeah, so you have a highly dynamic range image now that can be used in the later stages of using it in PTGUI and all that. That's it.